In section 6.3b, we're going to look at solving trigonometric equations that are more complex than the simple arc sine, arc cosine, arc tangent. We're going to deal with four types of equations. A single trig function, which means we've only got sine, cosine, tangent, secant, one type of trig function in it. Functions that involve multiple angles, such as 2 thetas, 3 thetas. And then the last two are quadratic forms. What we're going to look at today, though, are the single trig functions. And the goal with the single trig function is we're going to isolate the trigonometric function involved in the equation. In other words, we're going to get the trig function by itself, and then we're going to take the arc of that trig function. So if we have a cosine, we're going to get everything on the other side of the equal sign. Then we'll take arc cosine to both sides and simplify. Here are the 5 steps we're going to follow. First, we're going to perform all your algebraic operations until you have a quantity that is only the trig expression. So I'll add, subtract, divide, so that we only have either a sine, cosine, or tangent on one side. Second thing, convert so that your trig functions are either sine, cosine, or tangent. So if I had a secant, cosecant, or cotangent, I would get that by itself and then take the reciprocal. Step 3. Take the inverse trig expression to get the expression with the variable by itself. Step 4, get the variable by itself. And then 5, write your answer in terms of what the question is asking. And there's 2 types of things we'll be looking at. The first is if we want all solutions, you're going to have an n where n is any integer in your problem. And that's basically saying if I were to plug in n, I would get any answer that would work in that equation. And then if you have a specific domain, you're going to limit that answer to the domain, which we've done before. Now if we take a step back, you might be thinking, okay, what does this all solutions thing have to do with anything? Haven't we already done equations where we found solutions? And the answer is yes, to an effect. Remember this very first example we did the other day? The sine of x is negative square root of 3 over 2. The thought process we had was we knew sine was negative in the first or the third and the fourth quadrant. We took arc sine to both sides to get x by itself. And then we plugged this value into the calculator and we got our measurement in degrees. And we got negative 60. Then what we had to do is we added 360 to get 300, so then my answer would fall between 0 and 360. And then when you checked your work, you can see that these answers do equal negative square root of 3 over 2. So negative square root of 3 over 2, negative square root of 3 divided by 2, you can see right there is that negative 0.866. And your check that you did was with the sine of 240 and the sine of 300. Those also gave you those negative 0.866s. But some of you might have noticed, hey, if I do a check with this negative 60, it also works. So sine of negative 60 is also that negative 0.866. But we didn't include that in my answer because it wasn't within this domain. But there will be situations that I want to get all solutions. So I'd want to include that negative 60. But then if I've got that, I've got to keep on taking it to the extreme of coterminal angles. What happens if I subtract 360 from that? Well, then I've got the sine of negative 420, and sure enough, that's the exact same answer. And then if I subtract another 360, which takes me to the sine of negative 780, that's also the same answer. And then I could also go in the other direction of adding 360 each time. So if I had the sine of 300, let's add 360 to that, which would be the sine of 660. And you can see once again there's another negative 8.66. So even though we only came up with 2 answers right here, you can see there are a lot more answers. In fact, there's an infinite number of answers. So we're going to come up with an equation that represents every single one of those answers. And the way we're going to represent every single one of those answers is with an n. So we're going to solve example number 1 for all solutions in pi radians. The key here is all solutions. So that's going to tell me that I'm going to have an n in this problem at some point. 1 minus 2 cosine of x is equal to 0. My first step is perform all your algebraic operations so that you only have the trig expression on one side. So here I'm going to subtract 1 to the other side. So negative 2 cosine of x equals negative 1. And then we'll divide through by negative 2. So the cosine of x is a positive 1/2. At this point, I'm going to be able to ask myself, what are the two quadrants that cosine is positive in? And we know that it's going to be positive in quadrants 1 and 4 when I draw my reference triangle. And for me to find my first solution, I've got to take the arc cosine to both sides. Arc cosine and cosine cancel. So I'm left with x equals the arc cosine of 1/2. As we said, we're going to get two reference triangles, one in the first quadrant and one in the fourth quadrant. And we want the arc cosine of 0.5, which we can see is 60 degrees. Now I don't want to just plop 60 in. You can see I'm asking for the answer in pi radians. So even though this is 60 degrees, we want to think about that in terms of radians. And if you don't remember how to convert, or you don't know what 60 degrees is off the top of your head, remember your conversion is 100 or pi over 180 degrees. So this measurement right here is going to be a pi over 3 angle, as this reduces to pi over 3. And then down here is also pi over 3. So my first answer that I got is x equals pi over 3. The second answer, remember if we're going here, we're going to subtract that pi over 3. And this line right here represents 2 pi. 2 pi is the same thing as 6 pi over 3 if we look at a common denominator. So 6 pi over 3 minus a pi over 3 is equal to 5 pi over 3. If you wanted to, you could put this as 60 degrees and then down here say 360 minus 60 to get 300 and then convert as well. But since we're asking for pi radians, our answer has to be in radians. Now this is fine and dandy. Those are my two solutions that I get from just reference triangles. But I want all solutions. So I want every single time I go around the unit circle, every single time I get one of those coterminal angles, which is from when I add or subtract 360 degrees, or in this case, since we're in radians, we're going to say plus 2 pi n. Remember that 2 pi is the same thing as 360 degrees. So this equation says pi over 3 plus 2 pi n. That represents every single time I go around the unit circle. So realistically, what is this saying? So what does this pi over 3 plus 2 pi n mean? Well, we said that n is any integer. So I could take this equation, x equals pi over 3 plus 2 pi n, and I can plug in n as being an integer and get solutions. So let's say I let n equal 0. I could say pi over 3 plus 2 pi times 0. 2 pi times 0 is 0, plus 3, or plus pi over 3 is pi over 3. So there's a solution. I could plug in n equals 1. Pi over 3 plus 2 pi times 1 is pi over 3 plus 2 pi. And if I found a common denominator there, we know 2 pi is the same thing as 6 pi over 3. And pi over 3 plus 6 pi over 3 is 7 pi over 3. So 7 pi over 3 is also a solution. N equals 2 is an integer. So we'll plug in a 2 for n. So pi over 3 plus 4 pi, which is pi over 3, and then to convert 4 pi in terms of thirds would be 12 pi over 3. So then I get 13 pi over 3. 13 pi over 3 is also a solution. So every single time I plug in an integer in for n, I'm going to get another coterminal angle as my final answer. And I'm not limited to positive integers. If I wanted to, I could plug in a negative 1. So then I would put pi over 3 plus 2 pi times negative 1, which is pi over 3 minus 2 pi, pi over 3 minus 6 pi over 3, which gives me a negative 5 pi over 3. That is another solution. So you can see right here, it's going to be impossible for me to get all my solutions because I could do this forever and ever, plugging in integers in for n and getting answers. So this equation right here, this pi over 3 plus 2 pi n, represents all solutions for every single coterminal angle that we've got. So the key that you see right here is when you see all solutions, you're going to leave it in terms of 2 pi n or maybe a pi n, depending on the type of equation that you're given. But you're going to have this n piece in here indicating all solutions. So your thought process is the same as you had originally in the previous lesson, but since we're asking for all solutions, at the end we're going to plop this plus 2 pi n, which will represent all solutions. And what that means is if I were to plug in an integer 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, all those answers that come out solve the original equation.